answer, is the slope going to be positive or negative? This is a positive type slope. This kind of slope is what? Negative. So it better be a negative number. But this formula will tell us exactly what it is. What will it be? Negative 10. Okay? So, we did all this work, the derivative, blah, blah, blah. But the derivative is supposed to tell us the slope. That's the whole point. Not just like some formula, some limit calculation. It's supposed to tell us the slope. Now, one important point, and quite obvious though, is what is the slope right there? Without the derivative, just tell me. The tangent line, what is the tangent line there? It's a flat line, right? Right? So the slope of a flat line is what? 0. So the slope better be 0. And what does the derivative function tell us the slope is at when x equals 0? 0, right? Oh, it's working, right? It's working. Okay? Now, we did it for x squared. But we can do it for x cubed. So how about if we did the same thing? Now, suppose I change this whole sentence. I just changed it to f of x equals x cubed. And show that the answer, well, I already know the answer, but we really have to discover it. But I told you the answer is 3x squared. Okay, so what would you have to do differently now than you did the last time? You start with this again, but what would you have to do differently now? Instead of f being x squared, f is x cubed. So then this term is going to be what? Not x1 squared, x1 cubed. And this term is going to be what? Not x0 squared, but x0 cubed. And that's the only difference that's going to be there. But I think the algebra is going to be worse. Right? You're going to have x1 squared, x1 cubed minus x0 cubed. What are we going to do with that? Now, even though I, said, oh, everybody knows high school algebra, I actually don't know. I did know at one point, but I can't remember now. How do you factor x1 cubed over minus x0 cubed? Anybody remember? I don't. Anyway, we're going to have to do that in order to simplify it, in order to do the limit. Okay? So we have to do that and just keep working on it, keep pushing it through, and hopefully, I hope, that we would get this answer at the end, 3x squared. Okay? And then we can take this. Now what's going to be different over here? What's this going to be? x1 to the fourth, and this is going to be x0 to the fourth. Then you have to work on that algebra. That's obviously going to be worse, I guess. Actually, you can factor that, right? That one might not be so bad. Difference of two squares squared or something like that. Anyway, you can imagine doing all these things. Okay? And getting different answers each time, right? And each time you will have found the derivative. Okay? And that means each time you will know the slope for all of these different functions. X squared, x cubed, x to the fourth, and so on. Now, does anybody remember we don't cover this in our class, but just to remember. Anybody remember what this function looks like? We don't really need this, but let's just review it. See if we can remember what it looks like. So, when the angle is 0, what's the cosine of a 0 angle? 1. You remember that or not? Now, what's the next angle that you remember the cosine of? Besides 0. 90 degrees. Right? When it's 90 degrees, what is the cosine then? So if you have a 90-degree angle, like here, this angle here, what is the cosine? 0. So that's here. And what's the next one that you remember? If you talk about not this angle, but this angle, 180, then the cosine is what? -1. So that's -1 here. And then when you go back to here, what's the cosine? Do you remember? I mean, you can see what it is. It's 0, right? So at that's 270 degrees. That goes back to here. So what it looks like is like this. Like that. And it's repeating, right? Because you're going in a circle over and over again, right? And we don't usually use these numbers, 90 degrees, 180 degrees. We don't usually use degrees. We can measure angles with, instead of degrees, we can measure them as, we call the whole circle 2 pi, and some portion of that, like if you only go this far, that's only 1/4 of the circle, right? So that's 2 pi over 4, which is pi over 2. So 90 degrees is called pi over 2 instead of 90 degrees. And then this is pi, and then this is 3, what is this? 3 pi over 2, I guess, right? And whatever, okay? Okay, so anyway, hit this curve, right? So we could ask the same thing for this curve. What's the slope here? What's the slope here? What's the slope, right? Same thing. So we could use, how would we have to do that? We'd have to put cosine of x1 here, not x1 squared, like we did last time we did x1 squared, but we'd have to put what here? Cosine of x1, cosine of x0, and then we'd have to do a lot of trigonometry maybe to figure out the answer. But we could figure out the answer, and it kind of interesting is that the answer turns out to be, if y is equal to the cosine of x, it's been such a long time since I taught this, y prime, or f prime, the derivative, okay, let me call it f, this is f of f prime turns out to be minus the sine of x. Turns out, after you do all that horrible stuff that you'd have to do, when you put all of that into here, and some complicated work, but finally you just keep pushing it, and you can finally get that it has to be the sine of x, minus sine of x. Okay, so that's kind of interesting. That means that this tells you the slope for any place on here. So I want to know the slope right here, I want to know the slope right here, I use this formula. Okay? Okay, but we're not using that. We're not doing that. But just in case you want to know, the other one is, what if y equals the sine of x? What's the derivative of that? And that will turn out to be the cosine of x. Not minus the cosine of x, but the cosine of x. Okay, just for your back pocket, just in case you ever need that. You can keep that in your back pocket. Okay, any questions about that? All right, but one function that we do need to work with is not the cosine and the sine. but because we're doing some finance, we need this function. Oh, I skipped. I shouldn't go here yet. Okay, I'll go here. Now, before we do that, what time is it now? 38, we have 12 minutes. Before we do that one, tell me the answer to this one. Okay. Suppose that is the function. Tell me the derivative of this function. I put the y there just to remind you that this is also can be written like y equals 8x plus 6, but just suppose you have this function. Tell me that. Well, how do you have to do it? You have to do this, right? Well, the algebra is going to be much easier for this one than it was for the other ones that we did, because you're not going to get x squared here. It's going to be much simpler. But don't do that. Don't do it that way. Do it just because you know what we're talking about here. We're asking what? The derivative, but the derivative tells us what? The slope of the tangent line, right? But what does this function look like? Maybe we don't have to go through all the work to answer this one. What does this function look like? It looks like this, right? It's a straight line. And what are we trying to, what's all this derivative going to tell us? It's going to tell us the slope of the tangent line. But the tangent line is exactly the same as the line itself in this case, right? There's not, it's just, it's not almost a useless concept, right? The tangent line of this, it just doesn't even mean much. Right? So what is the slope of the tangent line? Or really, what is the slope of this line? 8. So that's the answer. Right? Now, all the work for the derivative is just supposed to tell us the slope of the tangent line, but that's going to be 8 everywhere. So the answer is going to be, or it better be, 8. So in other words, if you do that here, what should I replace this by? This one is going to be what? ax1 plus 6. That's going to be this one, right? And what's this one going to be? ax2 plus 6. And then the algebra is going to be not complicated. You don't have to do the difference of 2 squares or anything like that. It's just going to drop right out. And you're going to end up with 8. Okay? Oh? What is the derivative of this? 8. Okay? But what was this one again? What was this? 2x. Now this one doesn't have an x in it, in the answer, in the derivative. And this one does. Does that make sense, or is that something wrong with that? What does that mean? That means the slope for this function depends on x. And what does that mean here? It means the slope for this function does not depend on x. Does that make sense or not? Yeah, right, of course. Right? The slope doesn't depend on x, right? The slope is the same here, 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 right? Here, 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 here. Slope is always the same. So it doesn't depend on x, so that's good that there's no x there, right? If there was an x there, it would mean that the slope depends on x, but it's not there, so that's good. On the other hand, it's also good that there is an x here, because we expect that the slope depends on x when we're talking about a parabola. Right? Different x's have different slopes. Okay? All right, I guess we have a little time to do this one. So what about this one? So this one, if you do all that, so what are you going to have to do here? You have to take this function and put it in here, right? So instead of this, what am I going to get? E to the x1, and instead of this, what am I going to get? Now you're going to have to do some kind of crazy algebra for this. Or, I forget exactly what we have to do, but we're going to have to, bang it pretty hard to get the answer out of it. Okay, we're going to have to do a lot of stuff, but you can look it up. You can read the logic of what they do and see the answer. Okay? You can see how they work it out. Okay, I mean, it's not going to be quite as straightforward probably. Now, oh no, it is. I forget. Actually, it might be really simple. But anyway, whatever it is, it turns out this has a really weird answer. So let me just tell you the answer to that. So let me ask you, here's f. Here's f. Is the derivative the same as f? Is this the same as this? No, obviously not, right? X squared is not the same as 2x, right? Yeah, they're not the same, right? They're not the same. How about here? Here's f. Is the derivative the same as f? No, obviously not. This is 8x plus 6. This is 8. That's not the same. Okay? How about if I gave you this one? F of x equals x cubed. And I think we're going to assume that we know how to... The answer to this one is what? 3x squared. So, okay, here's f. Is the derivative the same? No, right? Okay, there's no function where the function is the same as its derivative, except this one function. You can prove that this is the only function whose derivative is the same thing as the original function. So that means that f prime is also e to the x, which is kind of weird. Because remember, this is the function. What does that look like, by the way? Remember, it looks like, what does it look like? Looks like this, right? Yeah. Looks like that. Now, suppose I want to know the slope right here. Now, let's say this is 1. So what's the height here? Not the slope. What's the height? That means I have to put 1 into here. So I get e, right? So the height is e, right? What I'm telling you is, if you want to know what the slope is here, it turns out to also be e. I don't know. That's just true. How about here? What's the height here? If x is 2, this is e squared, right? The height is e squared. If I want to know the slope here, it turns out that it's also e squared. That's kind of weird, but it's true. This is the only function that has this situation, where the derivative is the same as the function itself. You can prove that. You can start out with the idea, that f prime of x equals f, and just with that, you can prove that f must be e to the x. That means that the only time that f prime can equal f is when f equals e to the x. You can show that. I think it's not that hard, I forget. Okay? Okay, so actually now we've covered basically all of the basic functions, derivatives. Now, is it time to go? Not yet. Except we haven't talked about like this. X cubed, we know that one, right? But how about this one? So suppose we have that function. We haven't talked about what to do there. But you can just do it piece by piece. Okay, so you do this one. What's the answer to this? Just this piece? You do this one. What's this one? 2x. Now this one you do 8 times the derivative. Let me change this to 8. Let me just make that x. Okay, so now what do I do for this one? It's 2x, and then you have to multiply by 8 at the end. So it's 8 times 2x, okay? And this one, I guess it's just 1, and this is 0, right? Okay? So you can just do them piece by piece. And that's even true if you have like this. E to the x plus x cubed. So what's the derivative of that? You can still do it piece by piece. So what's the derivative of this piece? And what's the derivative of this piece? The easiest one to do. Okay. Is that? Okay, I just remembered we left one out, which we won't do right now. The last one that maybe we need to cover is, suppose f of x equals ln of x. We need to know what's the derivative of that. Okay, and then we're done. Okay, and you can always do this kind of, if you have many pieces, you just do them piece by piece. Okay? So, and that has to be proved, that fact, that you can do it piece by piece. And to prove that fact, you have to use this again, to prove that you can do it piece by piece, but we're not going to do that. Okay, I showed you where all of this comes from, but in this course it's more applied. You didn't choose to study